Hello to everyone. Now you should be hearing me. Welcome to the session focusing on the energy data spaces and the steps and pathway in order to transition to a more data-driven reality in the energy sector. In the specific session that I am moderating, and I'm welcoming all participants, we are going to focus on what are the latest advancements related to the common data spaces for the energy sector, what are the lessons learned, what is the experience, what is the hands-on experience on different platforms or different components that have been developed in the context of different projects that have been ongoing for quite some time, for the last 2.5 years in most cases. And those projects were funded under the topic of big data solutions for energy. Based on the experiences we have all acquired, and we will see in practice what are the solutions that have been delivered, we're going to make the transition also towards the newly launched energy data spaces projects, in which that are about to start, or in some cases have just started, in order to see what are the new challenges that are ahead of us and how they are shaping up their work towards common data spaces. Our agenda has been framed along the specific lines, so we are going to start with the results of the specific projects coming from the DDICT 11 objective. We will start with the synergy project that I am going to present and present a demo of the platform, but as well as the experiences and lessons learned. We will continue with the rest of the projects, BD for Open, Platoon, and BD for Energy. And then we are going to continue with the newly launched energy data spaces, 3 out of the 4 projects that have been funded, Synergy, Omega X, and NRShare. In the end, we are going to discuss what are the main challenges in the transition towards energy data spaces, and any other question, any other feedback you would like to ask from any of the speakers. Without any further delay, I'm going to continue after having this short introduction to the agenda and to the scope of the specific section. I'm going to start with an overview of the Synergy project. Before I start, just one word for me as well. I am Fenareti Lampathaki. I'm the technical director of Suite 5, and what I'm working on and my professional work is focused on data-driven solutions and AI. And I'm going to present the Synergy project, starting with what is the broad picture of the project. We have a very large ecosystem of different stakeholders, DSOs, TSOs, aggregators, retailers, and so on. They are all collecting different types of data. They're storing them in different systems in different ways. They need to leverage all this wealth of data that is hindered right now. And this is the main, let's say, challenge and the main topic that Synergy was trying to address. We have developed a big data platform and AI marketplace that aims at facilitating any stakeholder, not only our demonstrators, but essentially with the platform, you will see how it works in a few minutes. Any stakeholder can upload their data through specific pipelines they need to configure once, and that can be executed based on their preferences. They can increase their own data quality. They can control who accesses their data. They can also acquire access to other data assets, models, results, additional types of assets through smart contracts that are enabled through distributed ledger technologies, and they can also run different analytics pipelines, both for their own data, but also for acquired data. On top of the platform, we are building a number of energy applications that are exchanging data with the platform. They are retrieving the stakeholders' data from the platform. As long as they have active data contracts, they can upload their own applications data, and they can run different analytics pipelines over the data they have legitimate access on the platform. All the results of the Synergy project that are on the platform side, but also on the energy apps that have been built on top of the platform, they are being validated right now in 5 demo sites in Greece, Spain, Austria, Finland, and Croatia. The project has been ongoing for 30 months right now. A lot of results have been already produced. I'm just going to highlight very specific results, the reference architecture with an extensive number of components that has been designed in detail to support different user journeys on the platform, a number of use cases, and a very extensive number of business, user and technical requirements that have been elaborated. A number of business models has been also devised, taking into consideration the generic data perspective, but also specific needs of the representatives of the electricity data value chain stakeholders that we have in our project. And we have defined 17 data-driven business models that are currently being evaluated internally within our consortium and externally with some selected stakeholders in the context of our living lab activities. In order to model the underlying knowledge around the electricity data value chain, we have defined what are the data that need to be exchanged, what is the meaning behind the data, and we have consolidated this knowledge within our common information model. We will find out more in the next minutes in the next slides that I'm going to present. We have also released our platform, the big data platform and AI marketplace that is fully integrated. 26 out of the 28 components are fully integrated right now on release 1.0 that was available, that has been available since December. An earlier release, the beta release, was available since last June, as a matter of fact. So a lot of feedback has been already acquired by our stakeholders internally, and the maturity level of our platform is already quite high. Different energy applications, 12 applications have been already delivered in their draft version, in their alpha release, and they are also available to our demo sites, to our different demo partners. And this brings us to the part that I need to highlight, the fact that our demonstration activities are currently ongoing. The different demo cases we had defined have been elaborated in the past in detail, how the valuation is going to work. All this has been already in place, and right now we are in the phase that the different demo cases are being implemented. The data of our demo partners is from the very beginning of the project continuously monitored, and right now we are in a very, very good position to say that their data have been already uploaded on a very large volume. Right now we're almost near 1 terabyte of data that are available on the platform already, and soon we are going to open access to the platform to some external stakeholders apart from the winners of the open call that are going to deliver some additional energy applications on top of the platform that is already available. The different data services that we have built are focusing on different aspects around data management, data sharing, data analytics. I'm going to provide a very quick walkthrough, let's say, and then we are going to dive into the different user journeys that we are supporting in the Synergy platform, and we are going to see dedicated demo videos of the actual user experience. Starting with data collection, how data are ingested on the platform. We are supporting a number of ways to upload the data on the platform, directly on the cloud platform, but also on on-premise environments that are available to be installed on-premise on the different stakeholders, but also an edge version of the on-premise environment that can be installed on different gateways in order to prepare the data before they are uploaded to the platform. And this is something that was quite critical for stakeholders that needed to ensure end-to-end data security and that their data never leave their premises unencrypted. We support a number of ways to upload data, batch files, historical data that are on very large volumes available, APIs that are already exposed by the different stakeholders can be configured on the platform once, and the platform can call the specific APIs to retrieve data at the schedule they have set. They can push data to the platform utilizing custom endpoints that the platform can create depending on the data that are to be uploaded. And there is obviously, for the real-time streaming data, a streaming broker based on Kafka. The different stakeholders can push data, can send data to specific topics of the pub/sub broker that is available on the platform, or they can ensure that the platform gets access to a specific topic with the appropriate configuration if they have already in place a streaming pub/sub mechanism. Before the data are stored, it is quite critical to highlight that we are trying to transform the data, to harmonize them, to increase their quality. We are mapping always the data to the common information model. We are ensuring they are transformed to have common measurement units, common data format, and so on. And we can clean the data to ensure we don't have null values if we have any irregularities on the data, or anything that appears strange, that it can be addressed before the data are stored. In terms of security, we can also ensure that the data are anonymized before they are stored on the platform if they contain personal data based on different techniques we are supporting. The data can be also encrypted end-to-end if the on-premise environment is utilized. And once the data are available on the platform, the different data providers can define the exact access control policies that need to be enforced on the platform in terms of who can view, not acquire, because acquisition requires a contract in place, who can view the specific assets. It is an attribute-based access control mechanism that we are enforced across all different services on the platform. When it comes to data sharing, we are offering a data and AI marketplace where, as we will see in a few minutes, data sets, models, results are shared by different stakeholders as long as the access policies that the respective data asset providers have set. And the specific marketplace looks into and informs the different consumers of the data assets about the licenses, the IPRs, and in order to acquire access to a specific data asset, a contract must be in place. We are managing the whole life cycle of contracts, from the request for a specific contract, the creation of a draft contract, negotiation, payment online through cryptocurrency, and enforcing that the terms of use that have been written on the blockchain are really followed on the platform. In case we have multiple stakeholders involved on the creation of a specific data asset, as it might be the case for models or for results that are essentially derivative data assets based on data sets that may belong to different stakeholders, we ensure that the derivative assets become available on the marketplace only if there is the consent of the original data asset provider, and we ensure that if an agreement is reached through derivation contracts, that they will be properly reimbursed if the derivative asset is acquired by another stakeholder. Obviously, we offer search functionalities and recommendation services as well. The data analytics part, we are allowing the stakeholders to design different analytics pipelines. Those pipelines are designed on the platform. They can be executed on the platform, on the cloud. They can be executed on premise or on the edge, depending obviously on the configuration of the pipeline, depending on the analytics framework that has been selected and whether the specific pipeline can be really executed on premise or on the edge. We have also created a number of solutions, pre-trained energy data analytics solutions that are available on the marketplace, are available on the platform to address specific problems that we will see in a moment. And the user owns a specific pipeline, is designed, it can be configured, that it can be tested if it works as expected, and the results can be visualized. In our release, the first official release of the platform, we don't support yet the secure multi-party computations that will be available on the second release of the platform that is expected in December this year. Last but not least, we are also offering data governance services, starting from the fact that the common information model has a very crucial role on the whole operation of the platform, as you will realize in a moment. The model can be fully managed online, so there is no separate representation of the model offline and something else on the platform. Through the user interface, we can manage the model. Administrator can manage fully if new fields need to be added, new concept, in order to address new needs that may emerge from the different stakeholders. And this has happened quite often, I have to admit. Although the common information model was quite extensive from the beginning. The data lineage service and the provenance aspects of the datasets will be also visible in a very user-friendly way, but also on our last release. Last but not least, the platform management services are always necessary. We have an identity provider to ensure single sign-on for the platform and the different applications, an API gateway to ensure that if data are to be retrieved, that the stakeholders that want to retrieve specific data set, that they can do so on their own terms and create custom endpoints to retrieve data. And there is obviously an orchestrator to orchestrate all the different services that are running every moment on the platform. Right now, we are at the stage that at around 3,000 to 4,000 jobs are running every minute almost on the platform. This orchestrator is responsible for spawning new virtual machines, spawning new services to execute analytics pipelines or data checking pipelines, and ensure that everything works in an end-to-end manner without any problem. Starting with how the data are uploaded, what I want to highlight is that there is, we are allowing the different stakeholders to configure the data collection, the data checking pipelines once, and they can utilize them every time the job is executed. It is automatically, the configuration is available and the platform utilizes it. And the different stakeholders that want to upload data to the platform, they are free to choose what steps they want the data checking job they are defining to have. They can, for example, define that they want cleaning to be applied or not, anonymization is also optional, encryption is optional, and so on. Once the configuration is stored, it is triggered for execution based on the schedule that has been defined by the data provider. In this pipeline configuration, what is quite important to highlight is that the whole process is underpinned, the mapping step in particular, but it also affects all the next steps as well. It is underpinned by the common information model. We can just see an extract of specific concepts that have been modeled on our model. For each of those concepts, we have been inspired and we have followed different standards in order to ensure that we comply with what is the knowledge that has been already extensively modeled by different standardization committees. We identify the fields, the basic information that is behind each of those concepts and the relations between the different concepts. All this is managed online on the platform, and everything from the related terms, the fields, the relations, the mapping to different standards are kept online. Right now, our data model has over 100 concepts and over 3,300 fields in order to properly model all the data that are to be exchanged, and obviously this is going to be continuously updated. At this moment, I'm going to put a pause practically to go to a video in order for us to see how, in practice, a stakeholder can upload data on the Synergy platform. We can see directly the interface where a data provider can view the different data check-in jobs. He can create a new job. He can provide the name of the job. He can provide the description of the job. We can see the different pre-processing step. The harvesting step is always mandatory. He can select that for my data, I want to ensure that mapping and cleaning is applied. I want cloud execution to be applied, so I'm going to directly upload the data on the cloud. I create the specific job, and once I create it, I can configure the harvesting step. We can see that different methods are available. If I select the file upload, we also support other files. Any type of file can be uploaded. I have selected the third-party APIs here in order to show the configuration on a more complex case, but what I would like to highlight is that if we were talking about file upload, that we expect large volumes of data to be uploaded, there is a certain threshold that is already set on the platform on whether the specific pipeline will be executed in a normal way or whether a Spark execution will be triggered in order to ensure parallelization and that the execution of the job will happen in a quite performant and quick way. Assuming that I want to upload data, I already have a specific API, and in this case, I'm going to utilize an open API for weather data, a very common API, and we will see how the configuration goes in order to retrieve data from such an API. I am defining the request parameters, defining the API key that I have for the specific API. I'm mentioning that it should be treated as a sensitive parameter, so it should be encrypted, stored as encrypted. If my API needs any extra headers, anything special for pagination or anything, I can configure that, and I can configure the retrieval settings if the retrieval should happen immediately, once, or periodically according to a specific schedule. We don't require any change at all on the APIs that are already exposed by the different stakeholders, and this is why we allow, if, for example, the timestamp of the request was not supported, it is not included on the response, the user can store the specific data, they can store the data, and taking into consideration that we don't want any change on the APIs, the user, the provider can select which are really the fields that he wants the platform to eventually store. This is why we made a specific selection. Proceeding to the next step, that is the mapping step, where we are trying to identify how the source data are mapped to the common information model. The user identifies that whether the data comply already with a specific standard, and which is the main concept to which the data he is uploading refer to based on the different concepts that are modeled already on the common information model. I have selected the weather measurements in this case, and what we can see here on this interface is that we are facilitating the data provider to identify how their data map to the common data model. We have the source data that are the data as they were a sample as it was collected from the API on the first step on the harvester. An automated mapping prediction happens to the common data model, and we can see the confidence level that the platform has on the specific prediction it has made. Obviously, this can be corrected by the user. On the left, the user can see the specific extract of the model, the definition of the concepts. It can provide any additional information that is needed. In this case, he needs to provide for the temperature, for example, the measurement unit, in order to ensure that the data that are sent to the platform will be always transformed to a common measurement unit that is dictated by the data model. The user can also drag and drop, find a specific field he wants to map the data, and he can drag and drop the specific field on the data. I was just, while taking this video, was just checking something, so I was going back and forth, but essentially you can see that in an easy way, the user can validate also the, sorry, I need to stop. He can drag and drop the appropriate field from the common information model. He can validate whether the mapping is correct or any information is missing. If there is something missing, it is highlighted. And in this case, I needed to fill in the data format that was ISO based on the sample I could see. I can save the configuration. It is available anytime the specific API is used to retrieve data. It can be utilized. I can finalize the mapping, and then I'm ready to proceed with the next step, that is the configuration of the cleaning step. In this step, I can define constraints for my data, different types of constraints depending on the data type. For the temperature, assuming that I expect that my data in the country I am, they should be between 0 to 40 Celsius degrees. I mentioned that if the values are not there, they should be dropped. Or for the reported daytime field, I want to add the constraint that this field must be always present. Otherwise, if a record appears without that, you should drop it. It's not something that is valid. Once I configure the different cleaning rules, then I can finalize the cleaning, I can save it, finalize the cleaning, and then practically I can define what is the data set information. The specific job saves the data as a specific data set for which I am providing right now the title of the data set. I can finalize the data set, and once I do so, and the job is executed, actually, a new data set has been created on the Synergy database. I can view all the jobs, and we can see the notification that the specific job finished successfully. I had included that it should be triggered at once. I'm refreshing the page in order for us to see that the steps have finished successfully. If I visit a step, I can see statistics about what happened. One record arrived and it was successfully transformed. And I can view also the execution history if it was a recurring job that was supposed to happen very frequently. By visiting then the assets, I can view the assets, the data set of my organization. The first one is the one I just created. There is organization-based access, so you can see data sets coming from different members of my organization. But what I wanted to highlight is that I can define that the access level is private. I can share the specific asset under specific conditions, and I can define the access policies I want. And in this case, I want to deny other organizations to view the asset except for anyone from my country, from Cyprus. I cannot save, obviously, this because I have not provided all the metadata that are needed, the pricing details, the licensing details, and so on. I just wanted to highlight that the control of who views the specific asset on the marketplace always remains with the data provider. Moving on now with the data sharing and matchmaking services. Practically on the marketplace, we allow different stakeholders to find different types of data assets. We will see it very quickly in practice. They can request for quotation, they can, the data providers can check the specific request, and a contract process is followed. The contracts are always written on the blockchain, no actual data written, only the terms and hashed the terms in hashed form and the price. And once the different stakeholders reach an agreement, a payment takes place either offline for the datasets or through a cryptocurrency that is mandatory for results and contracts in general for assets that are derivative. And once everything has concluded and the involved stakeholders are reimbursed, the contract is activated. The metadata standard we have followed on the marketplace, it considers different standards, Dublin Core, DUCAT, etc. And what I want us very quickly, and I don't think I will show the third demo I have, I'm just going to show the marketplace only, not the analytics. So practically we can see a view of the marketplace, just the search interface. We can see different data sets, models, results. We can see that right now almost 250 assets are available through the marketplace. There is faceted search that is supported, but also advanced search to search really within the data and find the values one is interested in. He can get a quick overview on the right of the specific asset. He can view the details, the user. This is an asset that belongs to me. So I can see on the access policies what is the access policy that I have enforced and who can see the specific asset, the licensing details, pricing, etc. Going back to the marketplace, what you can see is that at some point I'm going to select, and I'm scrolling a bit quickly, I can add to cart different data assets that don't belong to me, or I can buy them one by one. If I add them to the cart, I can simultaneously buy many assets together by creating a bundle contract. This means that for each of those assets I have created, I want to buy them all at once, and I define the request, how the duration of use, what fields I want, etc., depending on the type of the data asset. I'm going to a draft contract I already have ongoing in order to show you the negotiation part, because it really takes a lot of time to show step by step the whole process. We can see a draft contract, we can see the license, the permissions, the cost, the payment details, and I can select to negotiate. I can change certain permissions that I'm allowed. I can reduce the price to negotiate the price. I can add new terms that I feel that the contract should include, just indicative. And the platform terms of use are always enforced, obviously, and I can sign the specific contract. I unlock my wallet in this case, and I included initially the password wrongly, but once I include it correctly, the specific transaction is mine, confirmed, and then the negotiated contract becomes available, the revised version of the contract. And we can see all the changes that were introduced while by myself. And the process then can continue on the same way. What I would like us to see right now is that once a stakeholder acquires through a contract a specific asset, he can see the specific asset as an acquired asset, no matter if it is a data set, a result, or a model. And I am just selecting randomly one of the assets I have for test purposes acquired. I can retrieve specific data from the data set I have defined. And I'm showing that in order to highlight that the way the data providers have uploaded the data, it doesn't mean that they become exactly or on the same way available to the different stakeholders that consume them. They can define specific retrieval queries, specific fields they want to get, which of those fields act as filters, and they can get custom endpoints that they can utilize on their own applications, or they can utilize the specific data sets they have acquired on the analytics part. And moving on the analytics part, the different stakeholders, either the data providers or the data consumers, can define different analytics pipelines including what is the input, different data preparation functions, different machine learning, deep learning techniques that they can train, they can apply, they can evaluate. The libraries we support right now are Spark MLE, Scale-Learn, TensorFlow over Keras, XGBoost, TMD, ARIMA, and Stats models. The configuration again happens once, and the user may define the schedule based on which the pipeline should be executed, once new data arrive, and so on. The data, the result, are saved, and they can be retrieved in the way I showed as the data sets, or they can be visualized on the platform. We are offering a number of pre-trained analytic solutions as well on the platform. All those solutions refer to comfort profiling, refer to demand generation forecasting, flexibility analytics at different granularity levels, short term, 15 minutes, at grid level, district level, building level, and so on. All those solutions have been created directly trained on the platform, or they have been created outside the platform and they have been registered, the specific models, in a specific way we support, since we don't allow any stakeholder to write code on the platform, to upload the specific models and make them available in a way that can be reused by other stakeholders as well. Apart from the platform, we already have a portfolio of different energy applications targeted to the needs of network operators, gas plant operators, energy retailers, and aggregators, but also for facility managers, city authorities, and ESCOs. We can see just indicative screenshots from some of the applications. All those applications are right now available in their draft release, and they are integrated with the platform already to retrieve data from the platform, to run analytics on the platform and display them on to the user. And this set of applications is going to be complemented by additional applications that are going to be delivered as part of the open call that is currently under evaluation on our end. To wrap up, some lessons learned and some things we learned, I wouldn't say the hard way, because we already had them in mind, and we were proactive enough to ensure that the platform already addresses certain of those lessons learned, but we were glad that those, let's say, expectations we had, they were confirmed. And it is a reality that the energy data come in different standards, many different formats. In many cases, we had very specific strange file formats that should be shared as is with other stakeholders, or they should be processed, very large volumes, or streaming data, very small volumes at real time, every minute or every 5 minutes. Many different restrictions. The data should be always on premise, they should not be visible by this, that, and stakeholder, and so on. So we should anticipate multiple ways of ingesting data without requiring any changes on the stakeholder side. And this is something that we realized that it was very much appreciated by our demo partners, that we offered a variety of ways to upload their data, and we didn't require from them to make any changes on their systems. Another aspect that is currently a trend on data management, we did not have the chance to address it as we wanted on the Synergy platform, but it is something we will do so on the future, as Tassos will present in a moment. Data observability, it is quite important to monitor the different pipelines, to identify if there are problems on the pipelines, if there are missing values, something that the data provider should take action, or if it is something that is at the hands of the platform to raise an alarm. So data observability, in order to not to lose any data and ensure high quality of the data, is key for reliable data. Data interoperability is always present. We cannot address it once and say that, okay, we created a perfect model and that's it. We need to change it. New needs arise, and there is no model that addresses every need of so diverse and so many stakeholders. The data sharing needs change. Different needs were expressed on the beginning of the project, and they evolve as we proceed and as the applications were shaped up. One thing never changed, that the terms of use, the IPR compliance, the respect of access policies must be always enforced in a way to ensure that the different stakeholders trust the platform, that no unauthorized access will be provided on their data. We are ensuring that everything that is happening in terms of data sharing is legitimate, with the legal representatives of the different stakeholders signing contracts, imitating what would happen on real life. And in the end, the last comment I would like to make is that it is not just about the data. The data are just the starting point. The data create and are the basis for creating different solutions, different results of analytics pipelines to train models, and we must always consider the extent to which the original data have contributed to derivatives, and to ensure that all the ecosystem, the rights, the different preferences are always respected when derivatives are created and are shared and traded. This is all from my side. Thanks a lot for your attention. There is a lot of work that has been ongoing, and the platform is already available, and soon we will admit external users. So if you're interested to join, please send me an email. And what is next, apart from the things that we have already planned on the Synergy project? Well, you will find out more by Tassos for the Synergies project presentation he will make in a moment. But right now, I would like to welcome Monica and Arturo, that are going to present the BD for Open project. The floor is yours.
Many thanks, Anareti.
Yeah, thank you very much. So if you can please confirm you can see properly the screen, would be great.
Yes, Monica, but not on presentation mode yet. Now it's okay.
Okay. So first of all, thank you very much for the opportunity to present in this event. We have entitled this presentation BD for Open Technical Challenges for Energy Data Management in the Upcoming Data Spaces. Yes, that's me. So my name is Monica Aragüez. Let's say that my work is currently focused on artificial intelligence applications for smart electrical grids. Okay, I have been working for more than 10 years in grid integration of renewables, mainly wind power and solar. And lately, my research work is more devoted to electrical distribution grids. I also take the chance to give the floor to Arturo, so that he can also introduce himself.
Thanks, Monica. Hi, everyone. This is Arturo Medela speaking. I joined Atos last year, and my professional work as of today, since joining Atos Energy Unit, is focused in energy and decarbonization. And my background, the previous almost 14 years, was basically in IoT, and well, that's what I bring in here. So let's talk about BD for Open and what can we offer.
Great. Thank you very much, Arturo. I didn't mention I am from CITSEA UPC, a research and technology transfer inside the electrical engineering department of the Technical University of Catalonia, and I am lecturer and researcher. Okay, so going directly to the project, I will be explaining the main objectives and premises of that European project and the pilot sites where it is being implemented. Arturo will be basically exposing the methodology for the architecture development, how are the data management processes, data ingestion, data access achieved in our analytic toolbox, and he will also present how do we ensure the secure access to the marketplace and the platform scalability. Okay. I will close the presentation with the lessons learned. So starting with the objectives, let's say that the appropriate processing of energy-related data, both operational and non-operational, can enable services that improve the decision-making process for smart energy systems operation and planning. Okay? This requires having access and sharing high-quality data in fair and transparently manner, okay, conditions. BD for Open promotes this, and it's based on these premises, and it allows not only data sharing, but also offering and developing analytic services that will enhance some processes in electrical distribution grids. Okay? So to visualize what we are developing, this is the analytic toolbox that permits to operate this energy marketplace, and that acts as interface between what we call data providers and what we call data analysts. Data providers are those agents that have access to data and that can feed the data lake with this data. They can be bringing data, for instance, from PMUs, from the SCADA, obviously from smart meters, also non-operational data, not coming directly from measurements, for instance, weather data. Okay, all this data, once appropriately pre-processed and processed, enables the services that are developed by the data analysts. And these services are thought to improve some aspects of the operation, the monitoring, the maintenance, the planning of electrical distribution grids. Okay, so basically, it's important to strengthen that in our project, the scope is electrical distribution grids and consumers. We do not include as stakeholder the transmission system operator. Okay? Some of the services being developed are grid topology, grid observability, predictive maintenance, fraud detection, energy management systems for households and for buildings, blockchain transactions, and flexibility aggregation services. Okay, so that's the idea. That are the objectives. Where are we applying all this? In 5 demonstration sites. These 5 demonstration sites include the grids of 3 DSOs. One of them is Estabanel, which is located in Spain. It is both a DSO and a retailer. It has access to data from more than 50,000 smart meters, and we can access to its SCADA, GIS, many grid analyzers. And it's interesting to know that among its assets, it has several PV small units, a battery, and EV charging infrastructure. For Elektrocelje, which is one Slovenian DSO, we also count with data coming from the SCADA, from geographical information system, and from grid analyzers. And among the generating units, they also have PV and hydro generation. Another interesting pilot site is located in Turkey. It corresponds to a grid from OEDAS. And apart from data from the SCADA, GIS, and analyzers, we count on data sources from electric vehicles, charging infrastructure, batteries, PV, hydro, geothermal, and wind generation. Okay. Apart from these 3 electrical distribution grids, we have access to an interesting pilot site, which is located in Bornholm, an island from Denmark, where 30 V2G chargers are installed with a power rating of 10 kilowatts. Okay. And additionally, there is a particular critical infrastructure, which is a microgrid located in the Brussels Health Campus, with access to data from smart meters, SCADA, GIS, and analyzers. It also includes PV generation, storage, and EV charging. Okay, so with this, I give the floor to Arturo to explain the methodology and architecture in our project.
Thank you very much, Monica. So let's talk about how do we do it within BD4OPEM. So let's start going quickly through the methodology that we are following in the project. And to do so, we can explain that the architecture in BD4OPEM was designed considering interoperability regarding both big data techniques and the interactions among energy assets. Also, we consider reusability. And of course, we also count on the versatility as one of our core principles. This architectural design is based on the deep analysis of both business and system use cases, reflecting ideas, requirements, and also constraints collected from our discussions with the representatives of the 5 pilot sites that Monica just presented, where our platform will be not only tested, but also demonstrated and validated. Using a standard IEC methodology, we were able to collect more than 35 use cases that we would like to address with our BD4OPEM platform. The model for our architecture is based on the Kratchen's 4+1 approach, and thus we count on 5 concurrent views, starting with the logical one, where we provide the description of each one of our architectural layers and the functionalities that are related to them. We continue offering the process view, where the description of the main processes and the interaction among tools is sketched. Afterwards, it's time to discuss the implementation view, which somehow drives the development in relation to the futures or the development from scratch. Then the time comes to offer the deployment view, which provides the mapping between every BD4OPEM tool and the specific pilot site where it's going to be employed. And finally, we have the so-called scenario view, which is no less that the summary, the recap on the different use cases that we are going to face. So you could please, Monica, that's it. Knowing this, we are trying to offer a leading edge architecture, which has as a foundation, open, innovative marketplace, which is going to be capable of providing valuable services for all the players in the energy chain. In addition, we want to count on beyond the state-of-the-art technologies of cloud computing with big data and artificial intelligence to build this open, innovative marketplace. With this in mind and knowing the approach that we were following, we have structured our BD4OPEM platform in 5 different layers. As you can see in the picture on the right, 4 of them are piled up, while the other one can be considered as holistic and cross-cutting. Then it all starts in the physical layer, which is the one in charge of providing the energy-related data coming from different data sources, field devices, and so on, deployed in the different pilot sites. Once we have data, it goes into the not originally called data layer, which is in charge of performing data interoperability between the other BD4Open layers. This is the case for the analytics layer, which in essence represents the core of the BD4Open solution. It counts on 6 different submodules, which are going to provide diverse edge energy solutions. Once apply this analytics over data ingested from the different pilot sites, it's time to put it into our marketplace, which acts as a virtual energy application store, so to say, for third parties to get a grasp of what we are offering. And finally, talking about this holistic layer, is the one devoted to perform actions related to security, privacy, and blockchain activities. In essence, this is the layer that ensures and guarantees the confidentiality, integrity, and availability of all the platform modules. Among the solutions that we are aiming to offer and proud to do so, we can distinguish between the ones directed directly to users and the ones that could relate to the grid itself. So when talking about the user solutions for the users, well, better said, and related to data, we want to make it manageable, protected, valuable, and of high quality. In addition, we will try to provide solutions to perform predictive maintenance activities. And for sure, what we are looking for is for a solution which is really easy to use and to manage. On the other hand, when dealing with the grid features, the aiming here starts by the use of high volume data, on the creation of data services. Also, we want to offer flexibility for our users. When talking directly about grid aspects, we are looking for valuable insights and ease of management as well. And as it was the case when offering solutions to users, we also look for a high data quality in these particular cases. And well, some time ago, someone in the BD4Open consortium asked, how do we manage so much and diverse data? Well, then we needed to proceed with the elaboration of a plan for our data management in BD4Open. And it's worth noting that in a project like this, building a common data model is particularly challenging. Why is that? Because we are going to include services that will need from a very wide variety of data type, starting with localization data, real-time and historic energy data, electricity prices data, also the weather that may generate a certain influx on what we want to measure and to offer, and also we list in here the topological data. And it also is a challenge because we are dealing with 5 different pilots located in really diverse countries, which present a different legislation. So it's another thing to handle with care. We detected the necessity of using different standards and not relying completely in just one. We mentioned in here that we took SARE4Renner as the baseline, but you can be sure we were not excluding any alternatives. And in fact, we needed to check a lot of standards in order to get the final flavor for our data model. Furthermore, several ontologies have been found to cover other specific additional aspects of the project. All in all, the BD for open data models are prepared to organize the data exchange in the project and somehow set up the foundation to determining which way the different elements that compose such data refer to each other, and also how they are going to match to real life entities and their features. We started from the analysis of the common attributes for these data models, and then we detected that a whole lot of possibilities appear and will follow our studies. The proposal for the data model to employ then appears to deal properly with measurements and statistics, as well as the subsequent the data model assigned to different elements, such as the electric vehicles that Monica were mentioning in our pilot in Denmark, the substations, or even field devices. So let's go quickly over the next few steps, where we try to explain how we proceed with the data ingestion from the pilots. And to do so, we are relying on this tool called Apache NIFI, where we have built different adapters that permits us to conduct the connection to the different pilot sites and perform the corresponding data ingestion. It gives us the ability to support multiple protocols for that connection, or for those connections. And we also offer different authentication options, starting with LDAP, Kerberos, OpenID Connect, SAML, or Apache Knox. And we are also taking into account the presence of the security information and event management. When someone, some service, some user, some data analyst wants to get some data from the data lake that Monica was mentioning at the beginning, we offer a couple of ways to do so. On the one hand, we have prepared the so-called unified API to let services access to real-time data, as shown in the figure on the right. But not only to real-time data, but also to persistence data, which is available in specific containers in the data lake. The use of such a unified API means that any underlying technology could be swapped out or replaced without affecting the services implementation. So this is a good point for our architecture. On the other hand, we have this distributed analytics engine called DI, which complements the unified API activity and eases the way how services data analysts gather data, providing partners in the consortium developing such services with a direct connection to the data lake and speeding things up in the process. To do so, we need, in addition, a secure access to our marketplace, and all the marketplace actors in BD4Open need to interact with their very own self-sovereign identity. This means they need to perform an account registration, not only for organizations, but also for individuals. The organizations with public decentralized identities on the blockchain are welcome. And these decentralized identities are provided outside of our platform. The account and service contracts issued as VCs is carried by the platform, and our SSI components are based on Hyperledger areas. I guess that we can go to the next step. And well, the idea is that the data space? Not yet, but give us a little bit more of your confidence and we will get there soon. So, Monica, if you want to wrap up with the lessons learned, perhaps we can go directly there.
Okay, so yes, I think that we have some lessons learned until the current development of the project. This implies identifying challenges, but at the same time, opportunities. I have been hearing at Fenaret explanation of Synergy project, and I see some common points in the lessons learned. On the one hand, the part of the IT infrastructure, let's say that it is key to ensure real-time availability of the data to enable some online execution of the services. And not all the smart meters or IT infrastructure gathering data from smart meter enables this. Okay. On the other hand, there are aspects related to data quality collection and governance. In this sense, the timeless integrity, accuracy, and consistency of data for energy AI applications still has room for improvement. What's more, on data integration and sharing, obviously the interoperability of data sets and data-driven solutions is key in order to ensure the wide adoption within many domains and many applications. And let's highlight that companies or some institutions are sometimes reluctant to share their data in order to avoid security risks or to unlock competitive advantages. There are also aspects related to data quality, which is essential to, let's say, deliver high or services that really can contribute to the decision-making process of what we are trying to enhance. Okay. And finally, some aspects related to data privacy and security. Lately, there have been an increasing raise of consciousness around, for instance, cyber attacks. So these are points that we need to strengthen and to still develop. There are some initiatives that are already looking at this. For instance, at European level, there is the legislation on Directive on Security of Network and Information Systems that, together with GDPR, I'm sure that can allow to strengthen these points and to pave the way of the future. Okay. With this, we can conclude our presentation. Thank you to all, to the audience, to the virtual audience, and yeah, the floor is yours.
Thank you, Monica and Arturo, for the presentation of BD for Open, and especially for the lessons learned and the approach that has been followed. I would like us to continue with the presentation of BD for Energy by Massimo and Vangelis, as we are running out of time. So let's proceed with the presentation of our next project for from DDICT 11.
Good afternoon to everybody. This is Massimo. Unfortunately, I was planning that the session was taking place within the planned time framework. So that's why I'm currently driving. And so I will be trying just while driving, just to going between two different meetings to introduce the BD for Energy projects. Anyway, together with me, there will be Vangelis Marinakis from Technical University of Athens, continuing and following up with focusing being within the project the pilot director, as requested by the organizers, just to focus explicitly on the results. Even if I have to say that BD4NRG is a younger project, so in comparison with the other three PIDS projects, was the one which was started 1 year after. So you can understand how not mature enough in comparison with the other three projects which have been presented are currently outcome. But in any case, we are trying to avoid as much as possible to focus on consortium project identity card and to go straight on just to focus on the vision and on how we are going to pave the way to prepare the ground for the energy data space. So as you can see in this slide, you can appreciate the BD4NRG vision for going from top down to bottom up, from the three different architectural layers for data governance and data management, processing and marketplace, going through what we call BD4Net, BD4DER, and BD4NF. So there are three different clustering from our 12 large-scale pilots. And let's go on with the slide, please, Vangelis. You can see that very quickly that this is what I said before. BD4NRG being started 1 year after is exactly in between the emerging paradigm of data space, in the sense that contractually speaking, we had the chance, differently from the other projects, just to adapt our work program and contract in order just to drive all the consortium, some of the technological components, especially just the connectors for user just access control, just to go towards the energy data, the data space implementation, even due to the fact that IDSA, Fiber, and other leading edge organizations are working in Gaia X, IDSA, and even in our project. If you go to the next slide very quickly, before to give the floor to Vangelis, you can see on the right our architecture, our technical architecture, and on the left some hints on the way through which we are going just to work towards this energy data space. So ranging from standardized data gates relying on SAREF, Fiber Context Broker, and EIC CIM automation standard for smart grid. And we are going to deliver just decentralized sovereignty preserving data access connectors, which are able to trade off data ownership versus management and data usage control and brokerage. We are trying just to set up within the data governance model hybrid data sharing models, which combine off-chain IoT data with blockchain smart contracts. And last but not least, we are evolving from a number of already completed recent ongoing projects, a P2P marketplace for reciprocal heterogeneous asset trading, in a very similar way to what Fenareti was telling about synergy, but widening the scope and giving the opportunity to utilize this marketplace as a way for, as a facilitator of data provisioning from the perspective of overcoming the end user energy consumers' reluctance to provide the data. Having said that, you can see in the following slide how we are going just to consider the cross-value chain services as the Ariana thread. So you can see how and which challenge we are going just to consider in our adventure, as Vangelis will be saying in the next slide, considering even the trade-off between additional cost for the technological infrastructures versus sharing economy business models for shared ownership, incentive splitting. And I believe that now it's time for going and focusing immediately on the concrete results. So please, Vangelis, the floor is yours.
Yeah, thank you, Massimo. In this slide, we summarize the BD4NRG reference architecture. We try to be aligned with the bridge architecture, including different layers from data sources, data interoperability, the functional layer, which provide the added value in terms of the different analytic services that can provide value to stakeholders in the energy sector, and the business layer, including different roles, different stakeholders in the energy sector. So in general, we are progressing quite well and developing technologies that meet the BD4 energy specifications. This is the architecture we have designed for governance, for data governance, and these are different components that are parts of this architecture. This is the data pipeline. We have actually the data from the pilots. These data are gathered within the landing zone. On top of this data, we apply homogenization functions and quality functions, and then stored within the HTAP lake or ingested directly using edge integration. Then we can have the mechanisms for ingesting data like streaming processing or batching processing. This data will be stored within the HTTP OLAP, and then we have a component, the integrated queuing engine, namely the interface between the data consumers and the data storage. So any application, any data analytic service can have access to all this data. So in the next slide, we try to have a small video. I hope we can see. Yeah. This integrate different three virtual machines, one for the HTTP component, one for the data hub for metadata component, and the VM for the integrated queuing engine. We have different roles: the data expert responsible to put data within the HTTP data storage, the edge gateway that we stream real-time data to the HTTP, and an external application that actually use the integrated queuing engine to get data for HTTP and to make analysis and processing. This is the HTTP lake. We have data for LSP1, the Portuguese TSO. These data are organized within a bucket, and these are the CSV files, and the relevant data follow a specific format. We can create a data pipeline based on the procedure we saw before. This is the Apache Druid we use in order to process the different data. This is something that we follow for all the CSV files. And then we can use actually sources. We can associate the data to metadata. This is the landing page of the data hub. We may have datasets, dashboards from Superset, different platforms to see metadata. We can go to Superset and see the dashboards like predictive temperature with different graphs and diagrams that present the different data sets available. This is the, we can see also the integrated queuing engine. This is also a few ingestions that specify how to get the data from a specific technology. And we can see in the video the relevant processes. This is the integrated queuing engine to request data, to join different data sets from different data sources and apply algorithms on top of this data. This is a working notebook which showcases the processing for the fault event analysis pipeline of the Portuguese TSO. We are able to read the metadata values related to the events, and the assets itself and visualize them. We perform fault detection to capture changes or fault classification. We are also able to extract automatically other relevant statistics, most related to the assets performance. So this was an indicative example for the data pipeline. On top of this process, we are able to apply different analytics services, giving particular emphasis on this cross-sectoral perspective that also Massimo presented before. So indicative example, we have the Tilos case, the Tilos community, where peak saving is achieved through smart scheduling of water pumping systems using novel deep learning forecasting models and advances valley filling or peak saving optimization algorithms. Other example, in the next slide, we can see the focus on the energy and the financing sector. For instance, we have developed a meta-learning classification model for supporting decisions on energy efficiency financing and the relevant investments using data from existing projects, from existing energy efficiency projects. We also apply federated learning to enable learning a single model across multiple distributed devices using local data samples. This applied to the management of the residential demand response assets to retrieve local grid information used for aggregation activities. And we also apply transfer learning. We focus on the exploitation, assessment, and implementation of a large variety of transfer learning algorithms to enable the training of complex models for predicting photovoltaic production, namely newly installed solar plants where data are not available, or cross-sector, cross-context transfer learning algorithms for residential flexibility asset profiling with a view to support to reduce the time necessary for model training and of course to optimize the management of assets. All these are indicative examples. Of course, this is something that together with pilots, we have 11 large-scale pilots organized in 3 main categories: BD4Net, focusing on the network, on DARE, on the distributed energy resources, and on energy efficiency. So using data from the pilots combined with other open data sources and so on, we are developing analytics that focus not only on the traditional machine learning approach, but of course giving particular emphasis on the cross-sector and other state-of-the-art analytic processes. And finally, to conclude, the upcoming days, we will also announce the open call of the BD4 Energy. So we are open to receive ideas, proposals from other company stakeholders related to BD4 Energy activities, the relevant services, and of course the application areas that are also main part of our project. So thank you very much for the opportunity to present BD4 Energy activities, and happy also to see other opportunities, cooperation with the other sister projects or other SMEs, companies that are trying in these open calls to propose their ideas. Thank you.
Thanks a lot, Vangelis and Massimo. We really enjoyed seeing a demo and where the different projects, let's say, stand right now in terms of achievements and in terms of what has been learned so far. So thanks a lot both to BD4 Energy and to BD4 Open for sharing their experiences, and considering that our speaker that would present the Platoon project, unfortunately, due to a last-minute emergency, could not be here. We are going to follow right now with the presentations of the newly launched Energy Data Spaces projects. So I would like to welcome now my colleague Tassos that is going to present the Synergies Energy Data Spaces project.
Okay, hope you can hear me, and soon you will see my screen also in presentation mode. Okay, so as Fen already explained, first of all, good afternoon to everyone. I'm Tassos Titsanis, and I'm the Business Development Director of Suite 5, who the company is actually also the coordinator, the technical coordinator of the Synergies project that will be presented, let's say, in the next minutes. And as you may realize, there is a direct relation and a continuation of the activities of the Synergy project presented before by Fenareti. With the short time that I have at my disposal, I will try to give you some further details of what the Synergies is about. And please excuse me if by mistake I confuse a little bit the two titles. It's difficult actually to converge from one context to another with a similar naming. But I will be talking about Synergies. So what is Synergies about? Actually, we saw a lot of functionalities, a lot of services, a lot of applications that are already provided by the previous projects, by the projects funded under the big data for energy topic. Now we need to move forward and try to establish the grounds for the common energy data spaces. So this is the main target of Synergies. And what do we mean by energy data spaces? Actually, in Synergies, we are trying to bring forward this reference energy data space implementation that aims at effectively integrating energy assets, data assets, and stakeholders across the energy data value chain, but also in relation to other coupled sectors that somehow at different levels and at different extent they affect the operation of the energy system and energy networks, in order, first of all, to facilitate, to enhance actually the resilience of the energy system by which is dominated actually by the uncertainty and volatility introduced through the wide penetration of renewables, the wide penetration also, the upcoming penetration of electric vehicles and new assets residing at the edges of the energy system, by increasing the data reach of the different stakeholders, actually giving them the ability to reach out to data sources and to energy assets that previously were beyond their reach, and created a great complexity and a great uncertainty in managing their infrastructures. And by allowing them to collectively, through this integrated ecosystem, this integrated energy data ecosystem, if we can call it better, to optimize the operations of the energy system as a whole, but also as individual components, in order to ensure the resilient operation of the energy system under increased digitalization, decentralization, and decarbonization terms, which are the main buzzwords right now around the smart grid and the smart energy system evolution. On the other hand, what we are aiming to achieve through the energy data space implementation that will be performed in Synergies is to facilitate, to utilize the results actually on the data side for the facilitation of the energy transition and with a clear focus on consumer empowerment. What we actually mean and what we actually target out of this process is, first of all, to allow prosumers that are currently excluded from most of the energy process, and actually we are focusing on small prosumers, residential or small SME prosumers. We aim to allow them to extract, to reveal, to understand their flexibility capacity, but not only this, it's the first step. As a second step in the process, we are trying and we will provide marketplace implementations in order to allow them to advertise this flexibility, to make it available, to make it known actually and advertise it, publish it towards aggregators or network operators, and in this way get involved in competitive processes and competitive transactions for the provision of flexibility services to the different layers of the electricity grid. And actually, we are talking about the transmission, both the transmission and the distribution grid, in order out of this process to, first of all, acquire significant benefits, get involved in, get actively involved in the energy transition and in energy transactions, and actually further motivate the creation of local energy communities through intelligence-enabled applications and services that we will be providing and we will be offering through the Synergies Energy Service Marketplace. So through Synergies, what we need to have in mind is that we are not only facilitating data exchange and data sharing, as you will see in the next slide, where we advance further what we have already developed in the ongoing Synergy project, but we also offer an energy marketplace, an energy service marketplace that comes on top and allows different stakeholders to make use of assets, of application assets that will be made available through the Synergies project. As I said before, and as Fenaretti also introduced in her presentation, the Synergies project is the newborn child of Synergy. Based also on the demo that we watched, which was too short actually to demonstrate the whole functionality of the platform, but I think it gave a representative view of what we can offer through the Synergy platform. Actually, we are stepping on the Synergy, on the fully operative big data platform and the analytics marketplace that we offer in Synergy, that is currently under extensive validation by a wide variety of stakeholders. At the moment, most of them are, all of them are internal stakeholders, but soon enough we will be opening also to external energy data value chain stakeholders in order also to further validate our results and to further promote, let's say, and achieve wider impact, let's say, for the whole industry. So we are stepping on the existing functionalities, on the existing data services, and we further enhance them on the data interoperability and governance part with services that were revealed out of our interaction with energy system stakeholders and were requested somehow as additional features that, of course, could not be introduced in the Synergy project, but now it's our opportunity to further enhance and pave the way for the transition to the energy data space reality. So we are enhancing the platform with additional data ingestion, data harvesting mechanisms, and standardized open connectors that will allow us to streamline to the extent possible the data collection from specific data and energy assets that are available on the prosumer side. We are introducing ML-driven curation and quality enhancement algorithms in order to further facilitate and uplift those functionalities available in Synergy. We are enhancing our interoperability mechanisms in order to be able to comply and align, harmonize information coming from coupled sectors, that is the mobility, the building sector, and so on, within a flexible structure that hopefully we'll have the opportunity to elaborate further in next events. And of course, we are introducing the data observability service as a key new service that has been revealed out of our interaction and the feedback provision from the validation of the Synergy platform. On the data security part and sovereignty, actually, we are introducing user-centric, data owner and data provider-centric, if we want to use the right words, mechanisms for enhancing access control and access policies enforcement over the data they make available through the energy data space, for data privacy preservation, data encryption, and data storage orchestration. And on the data sharing part, what we actually introduce as a key new feature has to do with the federated data sharing between federated data spaces of the different stakeholders involved in data transactions for the optimization of the energy system. And on the business side, because we talked before about monetary transactions and so on, what has been revealed also out of the Synergy project and the initial validation, the preliminary validation that we have performed, is that it is really important that when two stakeholders are collaborating for a common cause, it may be the case that the data exchange is based on not on economic incentives or on economic motivations, but could follow, let's say, the paradigm of a bartering economy, something like the Napster of energy. So this is another key feature that we are introducing, also addressing business perspectives and business requirements of the energy data value stakeholders. And of course, we enhance our data exploration and discovery functionalities through the marketplace, through the data marketplace, with more smart recommendations, matchmaking mechanisms that are intelligently proposing, let's say, assets that may be of interest to specific stakeholders, and of course, more advanced data retrieval and serving functions and services. From an energy perspective, and as explained before, I am giving here in this slide a very high-level example of how we are aiming to facilitate in a holistic manner, in a comprehensive manner, consumer empowerment and participation in energy services. So we are deploying a variety of solutions across different layers of the energy system, starting from the network, coming down to the community level, reaching even below to the building and the asset, the device level. And this is facilitated. These solutions are actually not facilitated, but they are built on existing digital twin tools that will be effectively enhanced in order to allow the convergence of the physical world with the AI and the data world, and somehow in this way adopt a hybrid approach in optimizing and performing more advanced hybrid simulations to deliver even more accurate results. So we are starting from the consumer side, the prosumer side, who will have the opportunity to make their data available to the different stakeholders for further analysis, for extraction and analysis of the flexibility. Subsequently, the data will be transformed to flexibility capacities in the energy terminology, and this flexibility will be traded at the local level between consumers, prosumers, and aggregators in order to create the critical mass to address the minimum requirements imposed by energy markets to participate in flexibility services for network operators. And a different marketplace implementation will facilitate the interaction and the transactions between aggregators and network operators, either TSOs or DSOs, for the provision of tailored services and dedicated services for the resilience of the respective networks. Together with this, the digital twins will be complemented with several applications that will allow the interaction of consumers, the interaction of the different users, and the guidance and the decision-making processes that have to be followed by the different actors involved in such a scenario. What I want to make clear, and I see Fenareti has already appeared there, so I will try to speed up, is that what we need to have in mind in the realization of such energy services and such energy scenarios is that all data exchanges will be performed through the data space. So we will not allow, if we can call it like this, we will not allow any data exchanges, direct data exchanges between specific stakeholders, but everything will be performed through the synergies data space. Analytics, also several analytics functions and advanced analytics functions, ML and DL driven, will be offered and will be designed as pipelines and models in the relevant tools that will be offered through the synergies offerings. And of course, all applications, digital twins, and of course, data assets, analytics applications, and so on will be available through the synergies marketplaces. And I will finish with some numbers, as is typical done in projects that are about to start. We are starting on the 1st of September. We are a consortium of 23 partners, and we will be working in these projects for 42 months. We have 3 large-scale demonstrators, one in Greece, one in Spain, and one in Denmark. 8 demonstration cases, 8 demonstration case types, if I can call it like this, that will be instantiated in the different demo sites to produce even more fine-grained demonstration cases per demo site. 4 digital twin implementations addressing different levels of the energy system, and 6 main end-user applications, and with a budget of 10 million euros that will enable the realization of our objectives. And finally, as I mentioned at the beginning, the technical coordinator is Suite 5, which I also represent, and the project coordinator will be TXT Solutions from Italy. Hopefully, in one of the next events, we will have our preliminary results to present, and of course, our project coordinator Michele will be also joining to further guide you to the different details.
Thank you.
Thanks a lot.
Thanks, Tassos, for the introduction of synergies. I would like to remind the audience, if you have any questions, please post them on the platform. Please post them on B2Match in order to be answered by the presenters in the end. I would like us to continue with the next energy data space, OmegaX, and Javier from Atos, that is the coordinator of the project, will provide us an overview. So welcome, Javier.
Thank you very much, Fenariti. Thank you for inviting me to present OmegaX. Happy to be here with such a lot of familiar faces and also with the project coordinators and participants. So hopefully you can see my screen, and I will try to present OmegaX as usual. Just a few words about me. This is Javier Valiño from Atos. I am heading the unit of for energy, climate, and decarbonization at Atos Research and Innovation, which is the means through which we go to these innovation projects at European level, and Atos as well. And me personally, I will be the coordinator of OmegaX project. I will start the other way as Tassos did. We are starting with a few figures and items regarding OmegaX as a whole. I would like to point out especially as for the partnership. As you can see, it's quite a large partnership, and we try to involve in the project both large, medium, and small energy partners, as you can see. So we have large DSOs at European level, such as EDP, EDF, or even transmission system operators such as Elia, also ENGIE. And we have also a number of small DSOs and energy players, so that we can make sure that whatever we are doing, it is backed up with the main actors on the landscape. So that's what I wanted to say regarding the partnership. And as you can see at the bottom of the slide, we just started the project this month. Well, really last month, so on the 1st of May, meaning that we are already active. So we will be happy to establish some collaboration links with the ongoing projects, both for the ones on big data we saw in the previous part, and also the ones on data spaces we are seeing now. A few things regarding OmegaX. So you can see at the very top of this slide our mission statement, which is pretty much aligned with the topic, which is essentially deploying a functional data space so that we can share data between appropriate actors along the energy value chain, and also trying to make sure that whatever we are demonstrating is meaningful and it is backed up with both relevant stakeholders and relevant data. And especially regarding data, I would like to draw your attention to the infographics at the bottom of the slide and also on the mid part, in which we are focusing what we have in terms of demonstration. We have 4 use case families, as we call them, and I will say a few words about them in the next slide. But as you can see, we are involving a lot of data sets, quality data sets. As you can see, more than 40 data sets aggregating together all the use case families, with 50 gigabytes in average for each data set that we are considering. And we are aiming at building some meaningful services on top of this data, which will be shared through this data space. And we will involve a large number of both data providers and service providers so that we can deploy these new services. And something I would like to stress as well, which is linked to both the objectives you can see on the middle of the slide, and also the instantiation of the reference architecture that you can see at the top left corner of this slide, is that not just Omega X, but all these energy data space projects are a lot about interoperability. We need to make sure that we are interoperable both inside the project and also outside with the other sister projects, as we are seeing today, and also with the projects that are outside the scope, and also organizations or associations that are driving this data space at European level, such as, for instance, Gaia X, IDSA, the Data Space Business Association, including also FIWARE, or even BDBA, DIDO, who is also very much into data spaces, as we can see with this session. So we will make sure that we are aligned with these sister projects and also these initiatives at the European level. Regarding what we call use case families, we have introduced this concept of use case families so that we can cluster the pilot sites we have in Omega X with different business needs we have detected in which we consider sharing data is meaningful. So we did this analysis of trying to select those use cases in which we consider that unlocking this data between multiple stakeholders will benefit the overall way we optimize certain things, such as, for instance, renewables. So we are approaching this from the solar perspective. So we are trying to investigate on use cases about solar technology so that we can make sure that all the relevant stakeholders, namely the solar farm operators, together with inverter manufacturers, the PV panel manufacturers, and also the DSO, can have online information and they can optimize everything together instead of optimizing each their own piece of the system. We are working also on local energy communities, which we think it is quite a meaningful use case because it is somehow a scaled down approach of the overall energy system. So in local energy communities, we have usually multiple energy vectors. We have small generation, we have flexible consumption, we have small storage, and we can therefore test there at small scale some advanced solutions that are somehow aggregating information from these multiple sources. We have as well electromobility as a way also to explore the connection with other verticals, in this case with the mobility sector. And we will be exploring some use cases regarding how to do, for instance, cross-border charging and also roaming of energy services. And finally, we are considering, as we saw, for instance, very much stressed both on the previous presentation of the projects on the big data call and also in synergies, we will also explore how can we optimize even more the way we approach flexibility, including these marketplaces for flexibility, whenever we are also sharing larger amounts of information from different stakeholders. And one important thing for our use case families, as you can see, they are each involved in several pilots, some in multiple EU countries, is that we are fostering what we call both intra-pilot and inter-pilot interoperability. By intra-pilot, we mean that whenever we are addressing a particular pilot site in a given country, we need to make sure that there is effective data sharing between the stakeholders that are involved in this particular pilot, so that we can demonstrate that it is true that by sharing this data, they are providing more intelligent solutions rather than the way they were doing it in an isolated way. And we are also approaching this inter-pilot interoperability. So as we are clustering pilots in use case families, they will be most likely dealing with the same or similar services or the same problems. So we will foster this benchmarking and cross-collaboration between pilot sites so they can optimize the way they are operating by having information of what are they doing in other pilot sites similar to the ones that they are doing. And for sure, not now because it is in an early stage, but in the future we have plans also for involving in the loop not just our families for use cases, but also the use cases from the sister projects on the same code. So this is something we would like to discuss with our sister projects. A few words in terms of how the work is organized. As you can see, we have a number of technical work packages. Those are the ones on the right-hand side that are marked in green. And they are both for the architecture use case definition together with the deployment itself of the data space, both for the federation part, the lower part of the data space, and the upper part, which is the part on marketplaces for both for data and services. We have our use case families, that those are the orange ones you can see at the right-hand side. And we have the purple work packages, which are the ones for cooperation and interoperability. So those are very important for us. And as anticipated, we will be paying special attention to what other projects are doing and also what other initiatives are doing in terms of data spaces. And on the left-hand side, you can see the iterative methodology we have proposed in order to follow this and try to make sure that we are effectively incorporating feedback from these external sources. And basically what we will be doing is doing 3 iterations, yearly iterations, so that whenever we finalize one iteration, we will produce some output we will feed to our sister projects and these initiatives at European level, and the other way around, we will make sure that we incorporate the latest updates on those for the next iteration so that we can follow up. And my last slide, and also a message for interoperability and collaboration. We have identified these 4 initiatives as the most relevant regarding data spaces at European level. So no surprises, they are the 4 associations that are part of the Data Space Business Alliance, namely IDSA, BDVA, Fireware, and GaiaX. And as you can see on the image, we made sure that we had the relevant contacts at each level. So we do have the leaders for GaiaX working group in energy, which is EDF, and also a number of core group members such as Atos, for instance, together with Engie or Elia. We also have the relevant contacts at BDVA. For instance, we as Atos are part of BDVA and therefore will be making this connection. And similarly, IDSA is directly working on the project. So that's also a very nice point of collaboration. And Atos as well is part of the board of BDVA. And finally, for Fireware, we have some members, including Atos as platinum member of Fireware. So at the end of the day, we will try to follow this lead in terms of where to look at to find some requirements and so on. And as takeover message, I would encourage all other sister projects to start aligning as soon as possible. We know that some of you are starting a little bit late after the summer break, but I would suggest, and this is an open question I leave for the speakers today, I would very much like to have this alignment after the summer break so that we can make sure that we are all on the same page, we are considering the same references so that we can effectively be interoperable and we can start the real work and the real deployment of our own energy data spaces in a similar way so that we can achieve at the end of each project this interoperability which is requested by the European Commission. And having said so, thank you very much again for inviting me, and I will be very much interested in hearing your questions, feedback, and happy to answer either now or offline. Thank you very much.
Thank you, Javier, for introducing Omega X. I think we should proceed with the presentation, the last presentation of EnerShare by Massimo. I know that we are a bit late, but we must be fair as well. So we will keep the session for a few minutes more open in order for to present EnerShare within the next 10 minutes or so. So
yes. Could you hear me, Fennaretti?
Yes, Massimo, we can hear you, yes.
Thanks. And again, since I'm struggling in a traffic jam in Roma, I'm really sorry for that, but I'm happy to be together with you again and seeing, as Javier was underlining before, a number of familiar faces and organizations around this project. My preliminary comment is that there is even a strong continuity between the, PIRS project, which have been funded in DT11 call a couple of years ago, and the energy data space call. So at least there is a good overlapping, which according to me is a good guarantee for having a good continuation of the work and trying to achieve really scalable results. And I take even the opportunity to come up to again to what Javier was saying before, that as from the mandate, from the request of the call, we need to be interoperable and we need to align one each other from the very beginning, possibly when all the energy data space have been started. Just to let you know that EnerShare project will be starting on the 5th of July, so in a bit less than 1 calendar month, but I heard that Synergy will be starting in September. So in order just to do the planned work on the interoperability, of course, there is a huge opportunity, different ways for becoming interoperable at use case, at architecture, it's, cross-testing of the pilot. So we have a world of the potential opportunity and we'll be really happy together with the partners of EnerShare just to share with you all this opportunity. So let's come up to the with very quick information on the EnerShare in a nutshell. So you can see how the consortium is, how much larger is the consortium. So the consortium is including 30 partners from 12 European countries. You can see even a geographical spreading of the partners in 12 European countries. But what is relevant for us is that we were able, during just the preparation phase, just to engage, to enroll a number of relevant partners, not only from the ICT perspective, but centered on the energy domain, but not only, again, centered into backed to the electricity domain, but especially backed to cross energy sector. So you can see that we are having 2 electricity TSOs, in particular LS and Nesser from Portugal, to see and even LS, it's quite relevant TSO because it's the actual chair of the R&D Innovation Board at ENSOE, and ENSOE, the TSO European Level Association, has provided the official letter of support. So we are having even this good anchorage to the requirements of the electricity, of the energy world. So not only having a good anchorage from the, on the association like DSA and Fiverr, all of us are truly represented here in the consortium, like it was in the case of the Omega X. So you can see that we have even one gas TSLs, one district heating network operator, 3 electrical DSLs, 2 large utilities like EDF, the leading partner for the Gaia X energy working group, and ENGIE as well. One big independent aggregator, Fortum from Finland, one ESCO, and some energy service provider, including even U-level association and SME. So it's quite complete consortium. According to us, could be hopefully a good balance between the ICT expertise and beyond electricity cross-energy sectorial domain, which is truly relevant in order just to achieve our objectives. If we go to the next slide, please. Very quickly, an overview of the project objectives. So we are having one architectural, I would say, objectives, whereas all the projects which have been presented before, we are going just to plan to extend and hybridize the GAN models and to contribute to therefore to the DG Energy Bridge cluster reference architecture with a specific focus not only on the electricity, but to widening the view and to try to involve as much as possible even beyond electricity utilities. And that's the reason why we have even not only involved a number of TSO and DSO working in gas and heat sector, but even we have planned just to capitalize on the use case which we deployed in BT for energy, which have been deployed in the bridge cluster and even in the Gaia X energy working group. We are having even Fraunhofer and TNO as relevant cross partners with Gaia X and ADSA in order just to expand this use case and to provide the opportunity for demonstrating in a data space perspective a new use case which could be provided even as a reference ones. One objective, number 2, is on interoperability, and again extending just this interoperability layer to other energy and non-energy sector, even while leveraging on existing ontologies, formal language like XRF, or even energy flexibility interface for other families of standards. We are having a trust and sovereignty objectives, which is aiming just to work together with the association for the IDSA and Gaia X in order just to further deploy these trust-related technological connectors while bringing center stage the blockchain and smart contract technologies, which we've started to investigate with a variety of common partners, including Atos and other Technical University of Athens, other common partners here participating to this working group in order just to try to see how this blockchain could be utilized in order to support even not only the marketplace level, but even the governance and the trust and sovereignty. There is one objective on the data value stack, and which is aimed to deploy this barter-like marketplace, like Tafos was saying before. And again, I'm happy to see that common deployments are planned or are ongoing. That should be reinforcing, hopefully, our common value proposition in front of our stakeholders, of the European Commission. And on the next slide, you could be having a complete vision of our objectives. So the objective number 5, at the level of services and digital twins, even here, it is fundamental to bring center stage cross-value chain digital twins. We are having the deployment, the demonstration of this energy data space along a variety of pilots. If I'm not wrong, we could be counting on 6 large-scale pilots. And the demonstration will be even aiming just to assess the technological stack, the use case, and to validate ranging from this intra-electricity to intra-energy and beyond energy use case. And last but not least, central to our, I would say, value proposition is the strong anchorage to this SSH, so to social science and humanities. So we are we have conceived our use case and our, technological implementation while being a suitable driven by SSH compliant or driven approach. And that's the reason why we have even engaged a number of relevant stakeholders in this field. Having said that, a very quick overview of the use case pilot. So you could see a wind farm maintenance along the supply chain optimization in Spain. In Portugal, we will be working on this cross-value chain for smart buildings, smart mobility, smart grid services, involving even power network operators, so at the interplay between the regulated domain and the free commercial one. The third one is quite interesting because maybe it's one of the first attempts just to deal with electricity versus heat within the perspective of a data-driven approach or a data space approach. We are having even an interesting power to gas optimal planning in Greece. And we are having even an interesting use case, which is at the interplay between the DSO and e-mobility and water. So the fundamental aim here is just to see how a DSO could be benefit from the interaction, from the perspective of gapping at latent and incremental flexibility from the cooperation with the two sectors. Normally, e-mobility versus DSO operators is something that it is not totally new, but would be innovative would be this triangulation, and how just to involve DSOs with e-mobility operators and with water network operators in Italy. Last but not least, in Finland, we are having a focus on this green energy production, flexible consumption. So this use case is going just to be backed towards the traditional flexibility domain. And last but not least, we are even in Latvia overseeing even interesting ESCO-based business, where we are going just to take the best and from data coming from the energy consumption versus energy investment plan. So as you can see, it's a wide, landscape of use case, considering not only electricity, but even the overall energy value chain in a beyond electricity way. You can see here an initial sketching of the high-level architecture, where you can see the different, layer from top down. Towards bottom up, you can appreciate energy data ecosystem going towards the data value, the interoperability, trust, and the connector. Maybe there should be the last slide, if I'm not wrong, or I don't remember. Okay, this is very quick. This is something that is based on our approach towards what Javier was envisaging before, and even on the behalf of NSR Consortium, I'm willing just to strengthen further just the potential cooperation in order to align our effort at different dimensions. So I would be really likely just to see a follow-up, ideally in September, October, waiting for a synergies project, and ideally there should be another project about to start in energy data space called maybe Data Center. Thanks for your attention, and I hope that this meeting will be even having follow-up in the near future in that respect. Thank you.
Thank you very much, Massimo, and thanks a lot to all speakers for introducing either results of existing projects or the projects that have just or are about to start in the energy data spaces. I think we have all concluded that we are going to renew this session in order to further discuss different aspects pertaining to the energy data spaces in order to reinforce the collaboration between the different projects. And as we have really run out of time, and I'm aware that many of the speakers and many of the audience need to leave, unfortunately, this time we have to skip the discussion slot, exchanging ideas on the main challenges that are relevant to the energy data spaces. But I am very, very sure that this is something we are going to discuss extensively in the months to come, together with all the projects that have been funded under the Energy Data Spaces call. So I would like to take this opportunity to thank to thank our speakers for presenting the projects they have been involved. I would like to thank the audience as well for hearing all the advancements and everything that has been ongoing over the last months and the last years on the different projects. And we will have for sure a follow-up meeting, a follow-up workshop to discuss the different directions that are opening up between the different energy data spaces relevant initiatives. So I would like to thank all speakers. I think we should all open our cameras if possible. And I think, Jaco, the floor is back to you. And thanks a lot to BDVA and the DIRE organizers for giving us the chance to have this session.